Great. So right now I want to talk a little bit about provisioning systems with Puppet. A lot of times when talking about Puppet, we're looking just at the configuration management aspect of it. After you actually built the system, then having Puppet on top of it to do configuration management. But for a show of hands, has anybody here actually used Puppet before to provision new systems? Okay, so there's a few people. Yeah, so there previously was the solution of Cloud Provisioner, which still exists for the time being, but we have a lot of new tools that are available for you to be able to use to be able to provision new systems. Specifically today, I wanted to talk about 3: Razer, and then some of our modules for cloud provisioning, and then the new module that's available for managing Docker instances. So to start off, for how people typically provision servers, there is usually like a few major methods. There is, doing it manually, actually having someone build out the machine and manually, installing whatever agents, maybe Puppet to get your configurations done, or maybe doing golden images, just using something like a VMware template and cloning things to be able to create new images. Or there might have been one-off tools specific for particular hardware platforms you might have been using. But for what we were trying to do, we already focus a lot on configuration management and have a lot of expertise around that. But we wanted to be able to bring some of the benefits that you see in regards to configuration management with Puppet to being able to actually accelerate provisioning systems with Puppet, to actually make it a little bit more seamless, to actually have it where when you're provisioning systems, make the handoff to be able to manage systems with Puppet a lot easier. So that's kind of been one of the recent focuses, and you'll see a lot of recent offerings from us trying to attack that. So to first start off in that regard, I wanted to talk about Razer. So Razer is our solution for bare metal provisioning. And what it really does is it allows you to, through Pixie booting, to discover new hardware. So when you first plug it in, boot up a machine into Pixie Boots, picks up a microkernel. And this is where we actually allow you to take advantage of the Factor application that we have as part of the Puppet Enterprise Suite. You can actually utilize Factor to be able to kind of inventory and inspect what that bare metal looks like. So things like how many processors does this system have, how much memory does it have, what's the storage look like, what's the MAC address. And then based upon that, you can create profiles or policies that allow you to match particular characteristics of that server to what kind of images should be actually deployed on top of that machine. Like, should this be a Windows server? Should this be a CentOS machine? What should it actually look like based upon those characteristics? So when combined with things like the new node classifier within Puppet Enterprise, or being able to actually classify nodes based on different facts that are available, this gives you the ability to kind of have a single touch experience where you plug in a machine, boot it up, it pulls down the appropriate image, and then based upon those facts actually goes through, classifies itself, and deploys an application on top of it. So to first demo that a little bit for you guys, I have my Razer server here. And I guess I'll take a step back to first define a couple of things. So to give you an overview of kind of some of the terms that are used when talking about Razer. There's things that we call repositories. These are generally going to be what ISO images you're going to be wanting to load on top of machines. These could be things for Red Hat, CentOS, Ubuntu, Windows, ESXi for laying down ESXi on top of hosts, those sorts of things. Tasks will be specifically for things like Kickstart files for particular jobs you maybe want to have run during the installation. Brokers will be for after the install for determining what to hand off configuration management to. In this instance, this is going to be Puppet Enterprise, but it might be open source Puppet or another application too. And then we also have tags, which are going to be the things that you're correlating those factor facts to. So kind of defining what the characteristics of a particular server should be and the policies around that for what images should be loaded on top of that. So switch over to my Razer server. This is going to be something that for Puppet Enterprise users in 3.8, there's just a PE Razer class that you'll be able to assign your nodes with to get Razer installed. You would have to bring your own DHCP server for actually having the proper tags for pointing to TFTP for standard Pixie booting processes. But to start off, I'll show you first Razer Policies. And then for here you can kind of see that I have two different policies defined. One is for smaller machines, one is for larger machines. Both of them are for installing CentOS. But you can see some different things that are going on around that. If I go to tasks, you can see these are some various types of tasks that you can have around for managing the installation of various different operating systems. Make this a little bit bigger. Is everybody able to read that okay? So this should allow you to be able to specify kind of what you want the installation process to look like based upon operating system, or if you want to just lay down the ESXi, for example. Then if I want to type in Razer Broker, at Brokers, you can see here that I have the Puppet Master specified. That's going to be the Puppet Master in my environment. So kind of what should be handed off after installing Puppet Enterprise, after the machine is provisioned, what actually should be taking over configuration management at that point. And so what I'm going to do actually is, now that I have that Razer's server actually set up, I'm going to go ahead and actually just go ahead and Pixie boot a new machine. So we can see what that process looks like. So we can see that right now it's first pulling down this microkernel image. Sorry if that's not. Sorry if that's a little small, guys. And as we step through this, it's going to boot into an image. See right now it's going to essentially be running Factor in the background to determine kind of what should be the policies that are in place for what should be installed.
Can effects in this process be custom?
In this process, no. So this would be things that are pretty much just at around the hardware and how it would look out of the box. The idea is there wouldn't really be too much that you'd be able to do kind of in a custom fashion at this state, but there would be. I'm trying to think if there would be a way, because we do have the method to be able to build your own microkernel if you wanted to do that. It's a little bit advanced and it would fall outside of our normal support structure, but if you wanted to kind of tinker, there might be a way to kind of inject some facts or something like that into there if there was something specific that you needed to be able to do. So you can see afterwards it ran Factor, it was able to kind of match it to a particular policy and actually begin the installation. So this is going to take a little bit. So one of the things I'll do in the meantime is just kind of step through what you would be able to do to define kind of what you want your tags, your repositories, and your brokers to look like. So this is all right now just going to be something that's managed at the command line. One of the things I did not show you is tags. So this is indicating kind of how Puppet is determining which tag or which particular classification should be given to a particular node based upon the facts. So, less than or equal to, the number of processors, and then you can tell which ones match a particular policy. And from there, you can match it to a particular image. If we switch over to the documentation, you can see the process for creating a new tag if you wanted to is pretty much just giving it a name, and it's pretty similar to the one that I have here, where you can name it small, the rule, whether or not you wanted to do some kind of equivalence test, and then what the fact actually is. So you can see this one based upon memory, is going to provision a particular image type. And then you can create your repository that's actually going to store your image, etc. see links, that's actually still going. So in the meantime, I'm going to go ahead and switch over and talk about some of the other provisioning tools that we have while that runs. And generally, since there's a lot of things I'm going to try to cover in terms of provisioning methods in this one, I'm going to be moving pretty quickly, but feel free to let me know if you guys have questions about any of the stuff you're seeing. Additionally, one thing that I will comment on for Razer is when you're using a policy like that, especially if you're going to be bringing up a lot of nodes, that would be a great time to look at the options around doing auto signing for certificates. So you can dictate kind of what you want your policy to be around what the host name should be for these new machines that are being created, and kind of what the logic should be for whether they should just iterate like host name, 01, host name 02, and then just counting upwards. And you can also kind of dictate what should be the auto sign policy for whether or not those certificates should be automatically accepted. So you don't have to manually accept that at the Puppet Master. So to switch back to my slides real quick, you can see that my CentOS box is actually booting up and fully installed. Yeah, it's not too slow. Switching back to my slides. Yep. There we go. So some of the other things that we have around provisioning that you're going to be able to leverage is managing cloud instances. So there was a couple of mentions of AWS already. And AWS is a new one of the supported modules that we've launched to be able to create new instances in the cloud and be able to actually define things such as, what should the security groups be for my AWS instance, for an EC2 instance? What tags should I have? What are the rules about how a particular node should be created? What block devices should be loaded with this or created with this particular instance? Those sorts of details you can start to pass in. And additionally, you can start to leverage some of the benefits that Puppet offers in terms of things like templates to be able to dynamically create your user data scripts as well for creating new instances in Puppet, or creating new instances in AWS. This isn't limited to AWS. We also have a module out on the Forge for Google Compute Engine as well. When talking with Brandon earlier today, he mentioned the $500 credit for Google Compute instances. And that's actually this top link right here, so I'll leave it on this slide for a little bit for you guys to be able to take note of it if you're interested in taking advantage of that. And additionally, this link is for the Forge module for creating new instances in the Google Compute Engine. I'll pause here for a second for you guys. Great, so to just give you guys a taste of kind of how that situation would work, let me circle back here on the node while it's up and running. So my CentOS node is finished being created. We go ahead and actually log in. So I have my new machine provision here. We can see that it's indicated right there in the first login that it was provisioned by Razer. And right off the bat, I have the ability to leverage all of the capabilities that Puppet has to offer. And even if I logged into the Puppet Enterprise console, we can see that my host 5 VM here has already been added and is ready to be classified. So if I wanted to have matching profile for classification that should have been done based upon those same facts, like how many processors a particular machine has, how much memory, what the hard drives look like, I'd be able to kind of start specifying, hey, maybe this is a database server based upon its hardware profile, and immediately start configuring it as such. So to switch back over to the EC2 example, I also have an instance set up in Amazon that is running a Puppet Master as well as a couple of nodes. And it's probably not a surprise to anybody that setting up Puppet Enterprise in any kind of cloud provider is going to be the same as you would normally normally have it for if you're running it on premises. But one of the benefits that you get now with having the EC2 instance actually being something that you can define in your Puppet code is you also get the benefits of using something like that Puppet resource command that we use for other kinds of native types. You can do the same thing with EC2 instances as well. So, since this is running in EC2, I can actually run something like this. And Puppet, the EC2 module, is actually going to be leveraging the Amazon API to make all of these calls. So it's going to actually be kind of inspecting the state of this particular instance that I'm giving it, and actually returning back the data around how I would be able to kind of recreate this exact same instance with Puppet code. So I can see currently it's running, what availability zone is currently running on, what my block device configuration looks like for this particular node, and so on and so forth. So what this really provides you with is the ability to start templatizing your EC2 instances, and for especially large teams that are maybe working in AWS, if you have people that aren't properly tagging their instances and saying who they were created by, and there's a lot of mystery around them, you can all of a sudden start to put some logic into that by enforcing particular tags to always be created based upon the person creating it, using factor facts or other kinds of logic that you have in your system. So in this particular instance, I have a couple of examples of things that you would be able to do to be able to keep things a little bit more simple or dynamic with Puppet. So you would be able to leverage, in this example, I want to create a few different nodes. And I have some profiles already created around what a typical Linux node should look like. And I actually created it as a defined type so I can instantiate multiples of them. You can see there's some parameters that I pass in, such as what the node name should be, what the availability zone should be, and where it should pull these from. And I can start to use things like params or Hira if I wanted to define kind of what my AMI images should be, etc. So if we actually take a look at my params class, you can see that right here I have it broken down by region as to what particular AMI should be used for different operating systems, based upon what region a particular user is in or they're setting up their instances in. And additionally, you can start defining these things like what security group should be a part of that particular instance, etc. So what I'll actually do is actually assign the Puppet code that I have around providing or provisioning new nodes. And another one of the benefits that you get now that it's defined in Puppet code is you can actually run a no-op run against this when you're actually provisioning new nodes. So if you have a large list of nodes that you want to provision, you would have the ability to simulate kind of which nodes are actually up and running right now, or if there's any that have stopped that you actually want up and running. You can kind of dictate that and simulate what those changes would be to your AWS environment, because that's all tracked in Puppet code now. So I can see that based upon the definition that I was going to pass it, it's going to create 2 new Linux nodes and a Windows node. I'm going to go ahead and get rid of the no-op. Based upon this, again, going to reach out to the API and create my new instances. So if we switch over to my console, my EC2 console, if I refresh, I can already see my new instances being created here and initializing. And if I take a look at some of the user data scripts that are being created, I can see that they were dynamically created based upon Puppet templates. So it has information like who created it, which is, my name is loaded in there. And it's based upon, the tags that I already have on the defined instance that I created. So if you have your Puppet master actually in AWS already, you can sort of track which puppet masters are creating additional instances and kind of keep track of it that way if you would like. Just to take another look at some of the things that you can do with user data scripts is there are a couple of default ones that I have here for Linux nodes as well as Windows nodes. If I take a look, I can see that I'm just passing in PowerShell code, but again, substituting in the appropriate Puppet variables when I find it appropriate. So, what particular version of Puppet Enterprise should be deployed in my environment, what should actually be the source of that particular Puppet Enterprise installation, if there's any files that I want to have loaded, or things like additional characteristics I want to actually put in the certificate request when a node is being created, I can do those things here. Okay, so again, I'm going to move kind of quickly here, but did anybody have any questions on that piece before I move over to the Docker section? Yep.
Where are your API keys and stuff that you're running all of those?
Yeah, so there's a couple of different ways you can do it. So if you go to AWS module, you can either do it with environment variables here, or you can use IAM profiles if you want to utilize that for kind of managing what your authentication should be. So this is probably the simplest way. You can either do the environment variable or stick your credentials in this your home directory, the AWS and credentials. And that's pretty much all you would need to do. Outside of that, you can get up and going. And probably it's recommended to be actually specifying your region, just because that will limit the regions that you're actually querying against with the Amazon API. So you'll get faster returns back, and you're not necessarily bombing every region with your API request to see what's out there. Yeah, definitely something that's recommended. But after that, you can start getting really creative around, what sort of things that you pass in and what parameters you specify. And again, to switch over to the Google Compute Engine, you're going to notice that it's going to be pretty much the exact same thing in terms of the things you can specify and what data you can actually fire up. And they even have some additional specifications around what you can do in terms of providing or provisioning Puppet Enterprise after the install. So that can make it a little bit more seamless without even having to specify the user data scripts and things like that. So to switch gears, how many people are thinking about or already using Docker? So there's a fair amount, and it's definitely one of the things that's very popular, and there's a lot of confusion too around how exactly can you utilize Puppet to be able to get kind of more benefits out of Docker. And one of the things that we have now is we have a supported module that you'll be able to utilize to actually be able to specify things like making sure Docker is installed properly, whether or not you want your kernel to actually be changed to the recommended kernel that Docker recommends, whether or not you want to pull down particular Docker images from the Docker Hub, and whether or not you want particular commands to be run on top of that particular Docker image. You additionally have some ability to specify things like if you already have Docker files that you have, you can specify in Puppet where those Docker files are, and then Puppet can actually handle running the Docker build commands to actually build up those Docker images as well. So to switch back over to my terminal, right here I have a couple of examples. And this is about as simple as it gets. Right now I'm specifying that I want Docker to be installed. I'm having it actually manage the kernel for me, and I'm also specifying particular DNS that should be used within my containers. Specifying that I wanted to download Ubuntu and tag it trusty, and then I actually wanted to just kick off a while loop just constantly printing hello world. Good. So I'm going to go ahead and kick off this run. You can see that it's going to go ahead and set up the repos for me. Get Docker installed. This is going to take a few minutes here. And while that runs, I'll go ahead and switch over to the actual Docker module so we can show some of the things that you're able to do. So you can include Docker and you can specify the images like I was specifying before. But one of the things that becomes really, really nice is if you actually want to specify something like a Docker file. So if you actually want to specify a Docker file, you can also pass that in and have Puppet build the particular image for you and actually start that up, have it running. And what this, really the kind of thing that becomes nice about this is if you have multiple Docker containers that you want to have interacting with each other, managing things like those port forwards, managing things like those mounts that you want to have with a particular Docker container becomes really simple. So for those that aren't necessarily 100% familiar with Docker and what it provides, it's generally going to be providing a container. It's a container instead of a virtual machine. And what that does is you're going to be kind of still taking advantage of some of the things that are installed on your operating system, like your kernel, to be able to actually run that container. But it creates an entirely different user space for you to be able to kind of isolate or containerize applications with it. So right now I can see that Docker has been installed and the server's been changed to running. So right now it's going through the process of downloading my Ubuntu image, so that's going to take a little bit of time here. In the meantime, are there any questions that people have over Docker and potential ways to implement that, or what the use cases would be? Let this run.
I'm curious if it would be nice to be able to actually, instead of a Docker file, use Puppet to just build your container.
Yeah, and so that would totally be something that it's reasonable to do. Depending on who you talk to and how much you want the Docker container to kind of stay true to their vision of being immutable, I have heard of people using Puppet, and they already have Puppet manifest for managing a particular application or configuration. Actually including that as part of their build process, running like a Puppet apply against a particular set of manifests, and then just pulling out Puppet or like making sure that Puppet's not actually running, so that after the Docker container is built, it still becomes that kind of container that is immutable. And then if you want to make any further changes, go through the process again, destroy it, build up a new container, and start over. So now that I have Docker all installed, I can go ahead and do a Docker PS. I can see my containers up and running. And then if I do a Docker attach, hello world, I get the very much expected hello world just constantly printing over and over again. Now this can get a little bit more creative, and obviously you can start leveraging some of the benefits that Puppet has to offer to make it a little bit more seamless. So I have another one that's a little bit different, Docker custom. And so this is going to do very much the same thing in terms of making sure that Docker is installed, but in this case I'm actually using a template to create my Docker file. So this would be something that you can do to, if you want to have it where the server that's actually building the particular Docker image can be kind of tracked or stored somewhere within your container. You can utilize this to do something like, hey, this container was created on this machine, or maybe a particular, if you do decide to integrate Puppet code into actually your build process for that Docker container, utilize what version of my configuration is actually being applied in, and actually put some of that dynamic data in there so you'll be able to reference it later. You can specify a custom Docker image based upon that file. And then I have another one here to actually run that a similar command to actually have it with cowsay read out, the content of that particular custom message that I have within my template. So if I go to templates, look at my Docker file, you can see it's pretty basic, just managing a couple of details around Puppet, and then I'm substituting in a particular variable from Puppet in terms of a fact that's located, so just its fully qualified domain name, into its message, and then I'm having Calce installed. So if I go ahead and apply this, you're going to see it's going to use the same image that it did before as the base, but then build a little bit on top of it. Do its apt-get update and apt-get install in the Docker file. And the big thing here is it's it's just something that you can get a little bit creative with. If there's a lot of Docker containers you're planning on managing on any particular machine, it is nice to kind of have consistency around what images are loaded on a particular machine, which ones should be purged. Is also a big one. It's very common after frequent use of Docker for a long period of time. You can have a lot of stray images, especially on servers that are building a lot of images. And especially when you're developing them and you're maybe not working perfectly every time right off the bat. So it becomes something that it's definitely useful to just be able to take advantage of. Oh, and it looks like something blew up. Yeah, gotcha. So it looks like something went wrong with my Ubuntu repositories, because Calce should be pretty standard. But generally the idea would be that you can see here, you can have custom information such as running the I was built on the master.inf.puppetlabs.demo environment. You can have that kind of data injected into your Puppet file and utilized as something that you can have within your Docker container. Unfortunately, sometimes demos blow up.
I love playing with Calce too.
Yeah. But yeah, that's generally what I wanted to show. Just kind of show you guys a taste of some of the different methods you can use for provisioning new machines with Puppet. So if anybody has any questions, that's great. If not, I'll see everybody at the social. So.
I think I have a question related to this, but I'm just kind of in my head thinking, is there a way to kind of have a base modules applied, right, to your environment, and then have it in such a way that you can separate like applications differently from that, so that you can have someone handle the application installs via Puppet, but the sysadmins would be just in control of a minimal base standard that goes across every box. You could only be controlled of that code, but that would also be in dev, prod, QA, and prod.
So what?
Someone do something extra apply on top of that.
Yeah. So the questions around what can you do in terms of kind of separating certain users should only have the ability to modify certain parts of your Puppet code and what's applied to nodes, and then there might be other base level system configurations that should apply across the board that other people control and maybe dictate around, right? So to do that, you would use our role-based access control that's part of the console. So here's some default roles that are kind of right out of the box available to you. But you also have the ability to create new roles, such as my team. Create role. Go within them, and I can select any users that I have in my environment. So if I have like users that I'm imported from Active Directory or things or groups like that, I can assign those to this particular group. And then I can start assigning permissions to this team or to this role, such as even whether or not they only have read-only access to the console. If there's someone that wants to like audit access, but they don't need to be making any changes, you can designate whether they have read or write access for that. You can go to node groups and then you can specify whether they can only create, edit, and delete child groups of a particular group. So that would be, maybe if you had somebody that's only in charge of the Razer server, you can add that permission, and then when they log into the console under classification, they'll only see the Razer server group. Everything else will just be a mystery to them.
But would that give them permissions to apply to every module that's in that group? You couldn't say, these are the base ones, A through C, or A through M are these modules, and then they can customize whatever ones that they want in addition to what we want.
Yeah, so if you were doing something like that, you might want to do a workflow similar to when we were talking about R10K earlier, where you could have that as part of the code management approval process, like what modules get pulled down and just who has right access to determine the modules. This is more for who has the ability to classify additional nodes with different code, who can modify in the console what variables are loaded on top of a particular public class or module. Yeah. Cool.
Excellent. Thank you so much.
Yeah.